Gears. In a couple of weeks we'll talk about belt drives. This week and next week we'll talk about gear drives. Both of those, gears and belts, can be used to change speeds, to go from fast to slow, and to transmit motion. But gears can do something that belt drives can't do. They can change direction, as you see here in these two miter gears, changing direction, for example. And they can transmit power because they're made of metal teeth. They do that efficiently. And another advantage of gears, while they are expensive, they last a long time. They have a long life. Let's look at some basic ideas about gears. When you have gears with teeth touching, we say they are in mesh. And when you have gears in mesh, you call that a gear train. So each of these pictures is a gear train. Now notice in this photograph of two gears in mesh, see that the teeth are curved. That's called an involute curve. And see that point where the teeth touch each other? That's the pitch point. The pitch circle is an equal distance from the center on each tooth, and the diameter of that pitch circle is called the pitch diameter. That's the point where the mating teeth touch. And that's what we mean when we say the size of the gear. So if someone says to you, this is a 4-inch diameter gear, if they don't say anything else about it, you can assume that that's a 4-inch pitch diameter. So the outside diameter might be a little bit bigger, but if they say a 4-inch diameter, they mean the pitch diameter is 4. Now the tooth size is called diametral pitch. And I have a note at the bottom here, the way we pronounce it. It's like the word diameter with an AL on the end, diametral. That's the tooth size when we're talking about gears that use inch dimensions. And you could actually figure out the tooth size if you knew the number of teeth and the pitch diameter. I like to think of it as teeth per inch. So that's the formula for figuring out diametral pitch if you ever need it. But what you need to know for now is that when you have two gears in mesh, they have to have the same size teeth. Otherwise they won't mesh. So if one gear has a size 4 tooth, the other gear has to have a size 4 tooth. Here's a page out of a catalog. You can see, for example, here's a size 2 diametral pitch. You can see that's bigger than a size 4 diametral pitch. In gears that are using the metric system, the tooth size is figured out basically the opposite way, and it's called a module. And we are not going to talk about metric size gears because it's easy enough to get mixed up if you're doing just one system. So I'd like to stay with the imperial system, but just know that a place like Machinery's Handbook has lots and lots of information about the metric system, and you can look it up there. Our textbook has information about the metric system as well. Okay, more about gears. When gears are in mesh, they rotate, if they're just regular old gears with teeth going around the outside of the gear, those are called external gears, they rotate in opposite directions, which maybe you'll be able to visualize. When one rotates clockwise, it drives the other one to rotate counterclockwise. And if you visualize these gears that are on the same shaft, visualize this shaft turning around, and it's taking these gears with it. If gears are on the same shaft, they have to turn the same direction, and they all have to turn the same speed because they're turning with that shaft. In a gear train, We call the small one the pinion. And the pinion is always the driver, so it's attached to the motor or the engine or whatever is driving the thing. And the pinion, the small one, always goes faster. You can maybe visualize this looking at this picture. Here is a gear train where the big gear has 24 teeth and the smaller pinion has 12 teeth. So now look at this picture on the right. When the smaller pinion goes all the way around a full circle, 12 teeth have gone around. But 12 teeth going around on the big gear is only half of the gear. So the little one goes all the way around when the big one only goes half the way around. The small one goes faster. And this gear train with 24 teeth and 12 teeth has a gear ratio of 2:1, twice as many teeth on the big one. And this gear ratio stays the same for the speeds. If you have a 2:1 ratio, the speeds are 2:1. The pitch diameter is 2:1. The number of teeth are 2:1. So that makes it handy for figuring things out. And when you talk about the gear ratio, you always say the big number first, or big number over small number. So faster speed over slower, bigger diameter over smaller, more teeth over fewer teeth. For example, here's another gear train that is also a 2:1 gear ratio. It has 40 teeth on the big one and 20 teeth on the pinion, so that's 2:1. So let's look at the gear ratio. For example, the RPMs, the revolutions per minute, you could figure out by figuring fast over slow, big number over small number. The pitch diameter, you could figure out big size over small size, 10 inches over 5 inches. The number of teeth, you could figure out big number over small number, 40 teeth over 20 teeth. And notice they're all 2:1. So let's go on to look at some questions in our quiz. We start out with this gear train, where this is out of our book. They tell us that this gear train has a gear ratio of 3:1. All right. And let's see if we could possibly fill in this table. So the little one, the pinion, is gear A, and the big one is gear B. So if the little one is gear A, and it has a diameter of 6, the big one must have a diameter that's 3 times as big, right? So if the little one is a 6-inch diameter, the big one must be what? 3 times must be 18 inches in diameter. If the little one, the pinion, has 18 teeth, and the big one has 3 times as many teeth, how many teeth are in the big one? Well, it must be 18 times 3 must be 54. If the little one, the pinion, is turning 1200 RPM, and that's the fast speed, now let's see, if the fast one is going 1200 RPM, and it's a 3:1 ratio, what speed is the slower big one turning? What is 1/3 of 1200 RPM? The big one must be turning what? 400 RPM. And now, what about the diametral pitch? It's a 3:1 gear ratio. If the diametral pitch on the pinion is 3, what is the diametral pitch on the big one? Ha ha, trick question. It's also 3, because diametral pitch is just the tooth size. So the tooth size on the little one is 3. The tooth size on the big one must be 3. And just thinking about the direction, the little one is turning clockwise, so the big one must be turning counterclockwise. Here's another gear train in our quiz. This might be a transmission or something. It has several pairs of gears. So in the first set of gears, 1 and 2, he tells us that the big one has 48 teeth and the pinion has 24 teeth. So what is the gear ratio? 48 divided by 24. We must have a gear ratio of 2 to 1. What does that tell us about the pitch diameter? If the big gear has a pitch diameter of 16 and we have a gear ratio of 2 to 1, what diameter is the pinion, the little one? And you could think about that with this, what do you call this, proportions. Okay, now let's move on to the next set of gears. Gears 2 and 3 are on the same shaft. So what do we know about that? Gears on the same shaft are turning the same speed and the same direction. So if gear number 2 is going clockwise, what is gear number 3 doing? It has to be clockwise as well. Now, let's see, so there's the direction. Did we miss anything? No, I guess we didn't. I want to say one more interesting thing about gears. This is not on the quiz, but you might like to know this. If a gear is turning a normal gear speed, a normal gear speed, it's going around, hundreds of times every minute. So these teeth are hitting many times a minute. And if you have an even number of teeth in both the gear and the pinion, then the same 2 sets of teeth are going to hit each other every time they come around. Bang, bang, bang. And of course, there are no perfect parts. So if there's some little imperfection on one of the teeth, it will wham into its mating tooth over and over again and cause tooth wear. If you put an odd number of teeth in one of them, like maybe in the gear, the bigger one, the gear ratio is going to be very, very close to the same gear ratio you would have had with an even number of teeth. But these gears will have to go around many times before the same 2 sets of teeth hit each other again. That's called a hunting ratio, when one of the gears has an odd number of teeth. So you might want to keep that in mind if you're ever designing a gear train and you want to minimize the tooth wear. Put an odd number of teeth in the big gear. Give yourself a hunting